All right, so let me now go to the table. So again, our z-score was 1.0714. As you can see, we're going to have to round. So let me stop sharing this thing. Okay. But if we look at 1 point, I think they can see it. Let me see. Can they see? Let me just wait. Oh, you got it now. Good. Now we want 1.0714. You can see that's not on the graph here, 1.0714. But what we can do is round it to 1 decimal place. So if you're going to use the table, we have to round to 1 decimal place. So if we round it, we would get 1.1. And we have the area, which is what we're looking for, because remember, the area is the same as percentage of data values for us. We get this. That's the area. And when we convert that to a percent, then we get the percentage of data value. Sorry if I misspoke just now. So the area to the left of the z-score is about 0.8643. That's what we're saying. 0.8643. Okay, so 0.8643. Let me get back to the notes. There it comes. There it goes. Okay. So for 0.8643 we got, that's what the table data, that's what the entry in the table is. Okay, so that's the area to the left of that z-score. So if we were to graph the normal distribution and look at the area to the left, the standard normal distribution, excuse me, and looked to the left of this z-score here, the area would be about this, 0.8643. The percentage then would be about 86.43%. So in terms of the word problem, about 86.43% of males have a systolic blood pressure less than 140. Now, is that good? I don't know, or if it's normal, that is, I don't know. But for the word problem, for now, that doesn't matter. We just wanted to get the percentage of data values, and we did. We got 86.43%. Okay. Let me just do this one then, although I think there's another part. Yes, there is. We'll get to that later. Now, what about less than 130? Well, we can use the same date. We can follow the same procedure. That is, we get the z-score for 130, okay? We convert it to a z-score like this, okay? Then we get 5 over 14, right? When we convert to a z-score, which is this. And on that table, I'm not going to go back to it, though. I'm going to go to Desmos in a second. Well, shortly, that is. But you would convert it to 1 decimal point, like this, 0.4, for the table at least. And then if you looked on that table, you would see the area, the area to the left of the z-score in the table would be this. Actually, let me just go to the table. It'd be easier if I had it in front of. It'd be easier if we had it in front of us. Here we go. Here it comes. Hold on. So we got about 0.35 something, but we rounded to 0.4, and this would be the area to the left. Remember, area to the left, right? We convert it to a percent, and that's how we get the percentage of data values less than this z-score. So in this case, we're going to get about 65.54%. So about 65.54% of males had a blood pressure less than 130. That was the word problem that we're dealing with. We could do this in Desmos, though, if we want. Let me actually do that in Desmos. So let me stop this. Let me get to here. So we're in the normal distribution. Again, we're going to work with the z-scores. So the z-scores we just got were this, 1.0714. That was the bigger one. And the smaller one we got was 3571. 0.3571. That's the z-scores we got, okay? So if we want the area to the left of 1.0714, that was 140, right? That was the z-score for 140 millimeters. For the blood pressure, that's the z-score. And we get about 0.8580, so about 85.8%, which is very close to what we got in our table, to what we have on our slide. I mean, we had to round it to 1.1. If we did type in 1.1, we would get this. See, you would get what we got from the table, approximately. That was close. That was fast. There we go. All right. Now, if we want for 130, the z-score was 0.3571. So let's type that in, okay? So in this case, right, we would have this. And we rounded, I mean, we did round to 0.4. For the table there, we got something close to here. But again, we get very close to what the table had. The table, there was some rounding there, which is why the answer was kind of off. So this is the area under the graph. Now, the last slide is actually getting the percentage of males who had a systolic blood. Yeah, let me just share it. Let me get to the slides again. Here it comes. Here it comes. There we go. So here, the last part of that question, right, is we want the percentage of males that had a systolic blood pressure greater than 130 and less than 140. I mean, we're basically going to subtract the previous answers, and then we convert to a percentage. Right? Because what we do is this is greater than 130 and less than 140. So we take what we got for 140 and subtract off what we got for 130. So we're subtracting. That's what I'm trying to show you here. Let me show you through Desmos. I think it's a little bit easier how to get this. So going back to Desmos again. Let me go back to Desmos. I know it's bouncing back and forth. Here it comes. Okay. Right, so for 140, we want less than 140. So that's less than 1.0714, right? That was the z-score. Greater than 130. And for 130, we got 0.3571. The z-scores, that is. So in this case, these are the z-scores. We want the area between this z-score and less than this z-score. That's what we have here. And this gives us the actual value. It's about 0.2185. So if you convert that to a percentage, it'd be about 22%. So, and that's pretty close to what we have in our table. Excuse me, in our, slides. So, I mean, I hope that makes sense. I mean, that's it for chapter 12. Are there any questions at all? Okay. So what I'm going to do now is I'm going to review. I'm going to start reviewing. And what I'm going to do then is I'm going to start reviewing. I'm going to start with stuff from chapter 6. Let me actually open it up. From chapter 6, remember, we dealt with annuities and all that. And I guess the impression I got was a lot of people were confused about this. I mean, it's understandable. It's not easy stuff. So what I'm going to do is show how to solve these kinds of questions What I'm going to do, though, is not use that TVM solver. I think most people did not like it. It could have been my fault the way I explained it. I mean, I tried to explain it as best I could. I'm going to show you using formulas, though. Okay?